Hi there, my name is Jakob and I'm an environment artist for Quixel at Epic Games. This is the 6th part of our extensive tutorial series about our medieval village demo project. After diving into how we approached set dressing in the previous tutorial, we will now look at adding light and atmospherics to our world. Especially, we'll go over how exactly we set up our dynamic lights, what other lighting techniques we used in this scene, and how we implemented certain atmospheric components such as the volumetric clouds and atmospheric sky. At this point, I also want to remind everyone that the entire project is available for free on the Unreal Engine marketplace for you to download and dive into. So, as always, without any further ado, let's jump in. Lighting in Unreal Engine is always an interesting topic with lots of choices to make, since the engine gives you quite a few workflows, all with different strengths and limitations. In this instance, baked lighting was out of the question, as one of the goals for this project was to have dynamically changing light based on the position of the player within our level. Ray-traced lighting, while admittedly looking absolutely stunning, would have been too expensive for this project, as we wanted to make it accessible for users even without the latest RTX cards. So, with our direction light and skylight now set to movable, you'll notice that everything seems to look a bit bland. If we were to use baked lighting, we'd definitely benefit from calculating very high precision indirect lighting, occlusion and shadows. Similar to using an offline renderer like V-Ray, the calculation of light would be inherently realistic. Dynamic lighting, at least out of the box, lacks these qualities. So, since we want to ensure that we also get nice looking global illumination and realistic large-scale ambient occlusion, we'll have to add ways to approximate these dynamically. This may not look as good as baked lighting, but it gives us much more flexibility for what we can do with our lighting during gameplay, and it allows for quicker iteration time, especially on a larger open map. Let's start by enabling SSGI, a screen space global illumination solution, by simply opening up our project settings, going into the Engine and Rendering tab, and enabling SSGI under the Lighting category. With a few console commands, we can control the quality of our global illumination effect, and our post-process volume allows us to also play around with the overall intensity. SSGI will also replace your default screen space ambient occlusion, so keep that in mind. Especially for this scene, where we don't really have a lot of artificial lights to brighten up nooks and crannies, SSGI allows us to add natural bounce light and visibility into these areas, even when we shift our time of day towards nightfall. With our indirect lighting sorted out, we also want to improve the ambient occlusion or self-shadow of this scene. SSAO is a cheap way of generating ambient occlusion in crevices and contact points, but due to its screen space nature, it is prone to artifacts from missing data off-screen and doesn't really do a good job of taking into consideration that nearby objects can also add ambient occlusion or indirect shadow to their proximity, especially on larger scales and tall asset clusters. This is where distance field ambient occlusion comes into play. To get the FAO working, we simply navigate to our project settings and enable Generate Mesh Distance Fields in the Rendering section. This will create distance fields for all of our static meshes, allowing the engine to calculate indirect shadow and AO based on field proximity and size. With our skylight set to movable, we can now see large-scale ambient occlusion being applied to our scene in addition to our small-scale ambient occlusion introduced by SSGI. The AO settings can be tweaked directly in the skylight, but I find that the default settings usually do a good job. Unlike previous projects, the medieval village does not use a skybox or Unreal Engine's default sky blueprint. Instead, we are using Unreal Engine's new SkyAtmosphere system. So once we made sure that both support SkyAtmosphere and support SkyAtmosphere affecting height fog are enabled in our project settings, we can then simply drag and drop a new SkyAtmosphere actor into our level. This system essentially simulates the behavior of a physically correct atmosphere in relation to your direction light as a sunlight. It contains a plethora of tweakable parameters, giving the user full control over the physical makeup of the sky. Using Ctrl, L and left-click drag, we can quickly move the direction of our main light source and see how it reacts with our new atmosphere. We made sure to provide links in the description below that will take you to the extensive documentation Epic provided, talking you through initial setup, all available settings and additional CVARs. Stuart de Young covers this system in his in-depth video on the Unreal Engine YouTube channel, for which you'll also find a direct link below. With a few final tweaks to that system, we're only really missing one large component. As you can see, we currently do not have any clouds in our scene, which doesn't quite fit the moody, overcast vision for this project. Again, we could tackle clouds in a few different ways, for example an added skybox that uses atmospheric sky and direction light data to tint and illuminate cloud textures. Or we could even opt for manually placing huge cloud cards. Instead, we decided to make use of the amazing new volumetric cloud systems that are introduced in 4.26. To use this new system, you will first need to go into your plugins and activate the Volumetrics plugin. Once that is done, you can simply drag and drop a new volumetric cloud actor into your level. You can see how, especially in conjunction with the atmospheric sky, we get some beautiful light play on the clouds. This gives us a good start, but can be pushed further. If you want to test out different settings and approaches, you'll find different cloud materials in the plugin folder, along with a demo map which allows you to play around with this system before adding it into your project or scene. I made sure to add some changes to one of the materials this system ships with, along with some adjustments to the actual volumetric cloud actor. With our clouds now looking beautiful and all of our other components established, we wanted to make full use of this dynamic setup and implemented a time of day system that would allow us to trigger different transition speeds and values for certain times based on the character's position in the level, even allowing us to integrate post-process settings per time of day. Chris Murphy did a wonderful job of creating that system for us, and he will dive into a thorough breakdown in one of his upcoming tutorials. Last but not least, we made sure to dress our level with various lights to give more depth to shapes and visual guidance through highlights. Lights can be a great way to highlight, if you will, important or walkable areas to the player. This approach is quite different from how you'd light for cinematic shots, as we are trying to highlight the basic flow from A to B so anyone playing doesn't get lost or confused about where to go. Important to note is that for all of the lights we are using values at least loosely resembling real physical values. While artistic license is definitely being used in order to achieve the mood we are after, a rough ground truth around which one can orient base settings is always helpful in ensuring a more coherent look. One last note is that especially point lights are notoriously expensive, so we made sure to disable shadow casting wherever possible. Now, thank you all so much for watching. I hope you enjoyed it. There will be upcoming tutorials further down the line on the Epic channel, where we will go further into detail on our time of day system and the landscape material setup, so make sure to stay tuned. As mentioned before, you will find all tutorials of this series listed in the description below. Please feel free to drop your questions or thoughts into the comments, and as always, I can't wait to see you in the next one.